Astronomers have detected a black hole that is currently moving. Scientists have previously theorized that supermassive black holes can move through space, but the ability to have caught them in the act has proven quite difficult and challenging. Currently, however, researchers have identified the clearest case so far of a supermassive black hole that is currently in motion. They have recently published their findings in a research paper. According to the researchers, they did not expect the majority of supermassive black holes to be in motion. They're usually content to just stay in one place. However, there's just so much that can happen with an object that is so heavy that it's tough to get them moving. Consider how much more difficult it is to kick a bowling ball into motion than it is to kick a soccer ball. Realizing that in this case the bowling ball is several times the mass of our sun, that's going to require a pretty huge kick. The researchers have been working to observe this rare occurrence for the last 5 years by comparing the velocities of supermassive black holes and galaxies. They have had their queries, one of which was, are the velocities of the black holes the same as the velocities of the galaxies that they reside in? The explanation that they received was that they expect them to have the same velocity. If they don't have the same velocity, that implies that the black hole has been disturbed. For their research, the team initially surveyed 10 distant galaxies and the supermassive black holes at their cores. They specifically studied black holes that contained water within their accretion disks, the spiral structures that spin inward towards the black hole. As the water orbits around the black hole, it produces a laser-like beam of radio light known as a maser. When studied with a combined network of radio antennas using a technique known as very long baseline interferometry, masers can help measure a black hole's velocity quite precisely. The technique that was used by the research team determined that 9 of the 10 supermassive black holes were at rest, but one stood out and seemed to be in motion. Located 230 million light years away from Earth, this black hole sits at the center of a galaxy that has been named J04372456. Its mass is about 3 million times that of our Sun. Through the use of follow-up observations with the Arecibo and Gemini observatories, the research team has now confirmed their initial findings. The supermassive black hole is moving with a speed of approximately 110 miles per hour inside the galaxy J04372456. But what's causing the motion is still unknown. The research team suspects that there are 2 possibilities. First, they believe that they may be observing the aftermath of 2 supermassive black holes merging, which would be the result of such a merger can be the cause of newborn black holes to recoil, and they may be watching it in the act of recoiling or as it settles down again. But there is also another supposition, perhaps even more exciting, of a possibility. The black hole may be part of a binary system. Despite every expectation that they really ought to be out there in some abundance, scientists have had a difficult time identifying clear examples of binary supermassive black holes. What they could be observing in galaxy J04372456 is one of the black holes in such a pair, with the other remaining hidden to their radio observations because of its lack of maser emission. Further observations, however, will ultimately be needed to determine the true cause of these supermassive black holes' unusual motion. Based on astronomers' statements, the physical processes that led to the formation of stellar binary black holes and their merger would have resulted from the evolution of massive binary stars. When they look at the physics of core collapse supernovae and the process of common envelopes, they consider this to be 2 of the main sources of uncertainty about the formation of binary black holes. Two black holes can form a binary by dynamically encountering into a dense star cluster. The dynamical formation leaves several imprints on the mass, spin, and orbital properties of the binary black holes. Approximately 4 years ago, astronomers detected the first gravitational waves associated with the merger of two black holes. This event marked the dawn of gravitational wave astronomy. They currently know this as binary black holes, and binary black holes do exist. They can reach coalescence by gravitational wave emission and are composed of black holes with mass ranging from few solar masses to approximately 50 solar masses. Of course, they would restrict their attention to stellar-born binary black holes. As to primordial black holes, which might form from gravitational instabilities in the early universe. They have also looked at discussing the binaries. In order to do that, they had to summarize the state-of-the-art knowledge about stellar origins in terms of black holes. This would be necessary to understand the pairing mechanisms of binary black holes. Like, comment, share, and subscribe. Let me know what you think about this fascinating discovery of a black hole in motion in a faraway galaxy. Thanks for watching. Goodbye.